Question is, a plane electromagnetic wave with magnetic field Hi milliamps per meter travels in air for z less than or equals to 0 and is incident normally on a lossless non-magnetic dielectric medium of relative permittivity 4 which occupies the region z greater than or equals to 0. Which one of the following is the expression for the reflected electric field? Here we know that E reflected is equals to gamma E incident. E incident equals to EI by HI is eta, that is EI equals to eta HI. So ER equals to eta gamma eta HI. That is nothing but gamma is eta 2 minus eta 1 by eta 2 plus eta 1, which is equals to minus 1 by 3. So eta is medium 1 intrinsic impedance, that is A, that is 120 pi. So ER equals to minus 40 pi cos of 10 power 80 minus beta z. Again this is x component, hence option A is correct. Question is, a microwave link operates under free space conditions at a frequency of 1 GHz, uses identical antennas at the transmitter and the receiver ends. The transmitter and the receiver are separated by 30 kilometers. If minus 30 dBm power is to be received when the transmitted power is 1 watt, the antenna gain should be. See, from the question itself that both the transmitter as well as the receiver antennas are similar, means both gains are equal, ZT equals to 0. Here PR is expressed in minus 30 dBm. That means in watts minus 30 equals to 10 log of PR by 1 milliwatt. So 10 power minus 3 PR by 1 milliwatt. This PR is going to be 10 power minus 6 watts. Here we know that PR is PT, GT, GR lambda by 4 pi R square. Here it itself is equals to PT G naught square lambda by 4 pi R square. Here if we substitute the given values, that is 10 power minus 6 1 watt G naught square lambda is, that is 1 gigahertz, means 3 into 10 power 8 10 power 9 into 4 pi into R is 30 kilometers whole square. If we solve this equation, we will get G naught as 400 pi, which is option D is correct.
Accidents occurring in a city in a day by Poisson variate with mean 0.8. Find the probability that on a randomly selected day there are accidents. So it is given that lambda, which is mean of the Poisson variate, as 0.8, and we have to find the probability that on a selected day there will be accidents. That means there must be at least one accident. So in order to find probability of at least one, it is enough to find 1 minus probability of no accidents. Now we know the formula for Poisson variate. P of x is equals to k, which is equals to e power minus lambda into lambda power k by k factorial, and lambda is given as 0.8. Now we need P of at least one accident, which is nothing but 1 minus P of no accidents. For this no accidents, value of k will be 0. Just substitute the values. E power minus lambda, that is 0.8, into lambda 0.8 power k 0 by 0 factorial, which is nothing but e power minus 0.8, 1 minus 1 minus, which is equals to 1 minus. If we simplify this value, it will be 0.449, which is equals to 0.551. Hence the required answer is option A.
Question is two-sided Laplace transform of x of t is given as follows. See, x of sum of two signals, one is right-sided signal and another one is left-sided signal. So the Laplace transform for this time domain signal is going to exist if and only if the ROC is, if there exists any combined ROC. Suppose x1t, if we take it as e power minus 3t u of t, if we take the Laplace transform x of s, this is 1 by s plus 3 and sigma is greater than 3. This is the ROC for this signal. If we take x2 of t, that is e power 2t u of minus t, the Laplace transform of this signal is 1 minus s minus 2. The ROC for this particular signal is sigma less than 2 here. So if we take sum of these two time domain signals, for that particular signal the Laplace transform is going to exist if there is a combined ROC for these two signals. That is, combined ROC is going to be sigma greater than minus 3 less than 2. So for this particular ROC, if we calculate x of s, we will get as 1 by s plus 3 minus 1 by s minus 2, which is equals to s square plus s minus 6, s minus 2 minus s minus 3, which is equals to minus 5 by s square plus s minus 6. This is for ROC sigma greater than minus 3 less than 2. Hence option A is correct.
In this problem, it is given that f of x is the solution of differential equation dy by dx plus 2xy plus 2x equal to 0, and similarly g of x is the solution of the second differential equation which is given, and also given that f of x and g of x have same constant values. That means the constant values of this solutions are equal. If they are equal, we have to check which of the options holds good. Now the given differential equation is dy by dx plus 2xy plus 2x is equals to 0. This can be written as dy by dx plus 2x into y is equals to minus 2x. So we can say that it is clearly in the form of first order linear differential equation, whereas p of x is 2x and q of x as minus 2x. Now the integrating factor is nothing but e power integral p of x dx, which is nothing but e power x square. Now the general solution. General solution of this differential equation is y into integrating factor, which is e power x square, is equals to integral of q of x, which is minus 2x, into integrating factor, which is e power x square, plus let us say some constant c1. Now this can be written as y into e power x square is equals to, we know the differentiation of x square is 2x, so it is in the form of f dash x into f of x, which is nothing but f of x. F of x is e power x square with negative sign plus c1. Now this can be written as y is equals to minus 1 plus c1 by e power x square, and it is given that the solution of this differential equation as f of x. So we'll replace this y by f of x. So f of x is nothing but minus 1 plus c1 by e power x square. So c1 by e power x square can be written as f of x plus 1. Let it be some equation 1. Similarly, if I find the solution for the next differential equation, which is dy by dx plus 2xy is equals to 2x, the difference between the first and this will be only minus. So even in this constant term also, there will be only a difference of minus. So f of x, instead of plus 1, it will become minus 1. So this is g of x, sorry. Let it be some equation 2. So from equation 1 and 2, we can write that f of x plus 1 is equals to g of x minus 1. So g of x is nothing but f of x plus 2, which is nothing but option A.